All right, good morning and welcome to Master Talker online class. If today is the first day of your watching our video, please click the subscribe button. Right, so let's solve this simple question. It said find the distance between these two things. Like I told you in our former video, this is the second video on longitude and latitude. In our former video, I told that anyone that is the same, if they are the same, then that is your alpha. So my alpha is equal to what? 3 degrees. Okay, but then your theta is now gotten from the remaining one. So but this is 65 north and 25 south. North and south are not on the same side, so I'm going to add. So it will now be 65 plus 25, so which will give you 90 degrees. Okay, so now the distance between them is very simple. And I told you that if you have the same if your alpha is gotten from the latitude, then it is distance from on a small circle. But if your alpha is gotten from the longitude, then it is distance on a great circle. So, and if you look at east, it is on the right hand side, so I'm going to draw like this. So if you are drawing like this, it is long, so the distance I'm looking for is on the what? Is on the great circle. But if you cannot remember this, just draw it. If you draw it, you can get it. So just draw a circle, do your cardinal point, or a sphere rather. This is my north, south, east, and my west. Okay, so I have that 3 degree east. East is on this side, 3 degrees. You see, this is my 3 degrees. Okay, then I have 65 degree north, like this. So this is 65 degree north, and then I have 25 degrees south. South is down, 25 degrees south, 25 degrees south. Okay, now where they met is the point. So this is my point A, this is my point B. Okay, so you see that the distance between point A and B is on the longitude. Why? Because they have the same longitude. Once they have the same longitude, then your distance is a distance on a great circle. Okay, so if you trace to the middle like this and trace to the middle like this, you can now get that this angle here is the 65, while this angle here is the 25. So the total angle between them is now 90 degrees. So, and distance on a great circle, distance between A and B is equal to what? Theta over 360 times what? 2 pi r. Right? So this is very simple. We will now have that what? 90 over 360 times 2 times 22 over 7 times 6,400. So if you do everything, you will now be getting that I don't have my calculator, so you can just press it and get your answer. All right? Okay, the answer here is okay, they say we should use our R. Sometimes they will give you R to use, please. They say the R that we are using is 6370. So the R we are going to use is 6370. But if they did not give you R, that is when you will use 6,400. Please, very important to note. So if you multiply, then you are going to have 10010 kilometer. Okay, so that is that. Very simple. So number 2. So you use the R that is given to you. But if R is not given, that is when you will now use 6,400. Okay, so I now have that they say that 2 places on the equator are this apart. Find the difference in the longitude. Okay, the difference in the longitude is the angle between them. It is called angular difference. Yes, angular difference. It is the angle between them. So we're going to have that the distance on the longitude, don't forget that distance on the longitude is called what? Distance on a great circle. I told you that. So, and distance on the longitude is given by what? Theta over 360 times 2 pi big R. So what do I have? They've given me the distance as 7,900. Okay, is equal to theta is the angular difference I'm looking for. Okay, the difference in their longitude, that is what I'm looking for. That is my theta is equal to 360 times 2 times 22 over 7 times 6,400. So therefore, my theta will now be 7,900 times 360 times 7 divided by 2 times 22 times 6,400. Okay, so if you want this to stay alone, the one down will go up, the one up will come down. So that is the fastest way to do cross multiply. So if you do that, you're going to have 71.09 degrees. Okay, as simple as that. So now let's talk about angle on a small circle, or sorry, distance on a small circle. The ones we have been doing so far, even in the previous video, is distance on the great circle. So let's talk about distance on the small circle. Right? So distance along small circle. Right? Now I told you that distance along the small circle is equally called distance on the latitude, because latitude is small. Okay, so distance on the latitude, and I told that it has a formula. If you have something like this, okay, let me just draw any one. Whenever they have a common latitude, maybe this latitude now is common to both of them, and maybe I now have a longitude and another longitude like this, for example. So when these two meet, they came to this place. Okay, so you see that the distance between this point A and point B is along the what latitude. Why? Because they have the same latitude. Once they have the same latitude, automatically it is called distance on a small circle. So, and the formula for distance on latitude or small circle is equal to what? Theta over 360 times 2 pi big R cos alpha. Please, the only difference between them is that in small latitude you must put cos alpha, and that's all. Very, very simple. Okay, so let us solve some questions to illustrate that. Right? Okay, so now they say calculate. The first question said calculate the radius of latitude, 75 degree north. Okay, the radius of latitude 75 degree north. Very simple solution. Now radius of longitude is big R. Okay, that is the radius of the earth, but radius of the latitude, small r, is given by that big R cos theta. You see how we got this formula in the other one. So big R cos theta. So very simple. This is what? 6,400 times what? Cos 75. So we have a 1656 kilometer approximately. All right, so this is very, very simple. But don't forget the radius of the earth is the same as the radius of the longitude. Okay, please don't forget that. So question number 2 said find the distance measured along the parallel of latitude, between two places with the same latitude 18 degrees south, and with longitude longitudes 96 degree east and 57 degree east. All right, so now I told you that once they have the same latitude, automatically the distance you are finding is distance on that latitude. So which is what? Distance on a small circle. Latitude. All right. So, but if they have the same longitude, then the distance you are looking for is on that longitude, which is distance on a great circle. Okay. So solution. Now they've given you that they have the same latitude. So my alpha is that 18 degrees. All right. Then my theta is gotten from the remaining one, which is these two, but they are on the same side, east. So I'm going to subtract. I'll say 96 minus 57. So 96 minus 57 will give you 39. All right. So I've gotten this. Even if you don't want to draw it, but let us draw it. Let us draw it to help illustrate it very well. This is it. You draw your cardinal point. This is north, south, east, and west. Okay. So the first one is south, and this is south. Face it down, facing south, 18 degrees south. And the other one is what? East. This is my east. This is another east. So the first east is 57, the smaller one, while 96, the bigger one. Okay. So where did they meet? They met at these 2 points. So if you trace them to the center like this, okay, you see that you're going to subtract because they are on the same side. And you see that the distance between these 2 points now, this is your point, the first place and the second place. See that their distance is on this latitude. So since it's on this latitude, it is what? Distance on a small circle. So we tell them that what? The distance between the 2 places, okay, is equal to what? Theta over 360 times 2 pi big R cos alpha. Very simple. Okay. So what do we do now? If you put everybody, you now have what? You now have 39 over 360 times 2 times 22 over 7 times 6,400 cos 18. So if you do everything, you are going to have that your answer finally is approximately 4145 kilometer. Okay, approximately 4145 kilometer. Right. So the next question number 3. See that longitude and latitude is even the first question you should rush in exam hall because it's very, very easy to draw, very easy to solve. So the next question number 3 said x and y are 2 places. X and y are 2 places on the earth surface, okay, such that x in bracket of what? 60 degree north, comma 30 degree east, right, and y 60 degree north again and 85 degree east. They now say find the sectorial angle xy measured along the parallel of latitude, okay, and then find the distance between them. The sectorial angle simply means their difference in latitude or difference in longitude depending on the one you have, okay. And anytime they write something in coordinate like this, latitude comes first before longitude. So since the latitude are the same thing, so I'm getting my alpha from the latitude. Solution. So let's just find the difference. Find the distance between x and y. All right. So now our alpha is gotten from is 60 degrees, the one that is common, like I told you. Then our theta is now gotten from the remaining one, and they are east. So I will subtract 85 minus 30, which will give you what? 55 degrees. Okay. So since I've gotten this as 55 degrees, if you like, you can draw. You can try drawing it if you want. So, but if you look at this now, you see that the one they have in common is the latitude. Since they have the latitude in common, this is distance on a small circle because the latitude is common. So, and this is called the sectorial angle between them according to what they asked there. So this one is the sectorial angle between them. Okay, all right. So I'm going to have that the distance between x and y is equal to what? Since the distance on a small circle, I'm going to say theta over 360 times 2 pi big R cos what? Alpha. Very simple. What do you have? 55 over what? 360 times 2 times 22 over 7 times 6,400 cos what? Cos 60. So what do you have? Don't forget that cos 60 is half. So if you do everything, you are going to have so press it in your calculator and tell me what the answer is at the comment section. All right. So they can decide to ask you only the radius, the radius of the small circle, or the, okay, look at what they asked there. If the radius of the earth is 6,400, find the radius of the parallel of latitude. They can ask you the radius of the parallel of latitude, and you know that radius of the parallel of latitude is given as small r, and small r is equal to what? Big R cos what? Cos alpha. So you will now get is 6,400 times cos 60. So which is what? Half of it. Cos 60 is 1 over 2. So half of this will give you 3,200 kilogram, kilometer. Okay, so that is that. So but the distance between them is now, press everything here, you get your answer. Right. So you see that longitude and latitude is the simplest question you can solve in exam hall. So let's keep solving. Right. So the next question here said 2 points x and y are on latitude 50 degree north and are directly opposite each other. All right. Directly opposite each other, full stop. Then I say if the longitude of x is 50 degree east, all right, then I say what is the longitude of y? Solution. Okay, they say what is the longitude of y? Right. Now if point x and y are directly opposite to each other, so let us just draw it. I have that this is my circle. I now have that this is my north, south, east and west. First of all, they say that 2 points x and y are on latitude 50 degree north. So this is my 50 degree north, 50 degree north. All right. So they now say that x and y are directly opposite to each other, and x is 50 degree east. So 50 degree east is this side. So I will now draw my and call it my 50 degree east. This line is my 50 degree east, and this is the point they met. This is my point x. If it's directly opposite to each other, here is going to still be the same 50 degree west. All right. If they are directly opposite to each other, so this is where they met. This is my y. So my y is what? 50 degree west. Very simple. Okay. The latitude of y, you tell them the latitude of y equals 50 degree west. As simple as that. They are directly opposite to each other. All right. Now what do they really mean by directly? Like if you carry this one and move it to the other one, it's the same angle that you are making, but not on the same side, on opposite side. All right. So the next question, they said a latitude A in bracket of 60 degree north, comma 45 degree east, and B in bracket of 60 degree north, comma 15 degree east, All right. They now say are two towns. Are two towns on the earth surface. Are two towns on the earth sorry. All right. Are two towns on the earth surface. They say calculate to three significant figure. Okay. Calculate to three significant figure the distance between them along the parallel of latitude. Calculate to three significant figure the distance between them on the parallel line of latitude. Right? So this is very simple. So what do? Even if you don't want to draw it, but let me just draw it for drawing sake. But even if you don't want to draw it, you still get your answer. So let me just draw it for drawing sake. This is my north, south, east, and west. I have 60 north, okay, 45 east, and 15 east. So 15 east should come first, 15-degree east, and then 45 east, the same east, 45-degree east. So they met here and here. The one with 15, this is my B and this is my A. Okay, so you take them to the center. So since they are on the same side, I'm going to subtract. My alpha is the one they have in common, which is 60 north, 60 north. So my alpha is 60. But my theta is gotten from the remaining one. And since they are east, east, I must subtract 45 minus 15. So my theta is equal to what? 30 degrees. All right. So you are done now. So the distance between them, if you look at it, is on the parallel line of latitude. And they have already given you that. And latitude is small circle. So I have that what? Distance between them is equal to what? Theta over 360 times 2 pi big R cos what? Cos alpha. So I'm going to have what? 30 over 360, okay, times 2 times 22 over 7 times 6,400 cos 60. And cos 60 is half. If you do everything, you're going to have so if you do that, where is the question? Because I don't have my calculator. If you do that, you're going to have 1676.19 kilometer. But they say in three significant figure. Three significant figure means start counting where you see number. So 1, 2, 3. So it will now be what? Approximately 167. Every other thing turns 0. 0.00 kilometer. So 16. Okay, sorry. 1, 2, 3. But the next one is up to 5. So call it 1 and put it here. It becomes 8. So it will now be what? 1680.00. Okay. So that is that. You see that this question is the cheapest question you can solve in exam. But in exam, please, if it's theory, draw it. Drawing it will fetch you an extra mark. Please, very, very important. Drawing it will fetch you an extra mark. Okay. So let's have another question here. They say an aeroplane flies at 650 kilometer per hour, all right, along the parallel line of latitude, okay, from point X in bracket of 15 degrees south and 10 degrees west, right, to point Y in bracket of 15 degrees south and 48 degrees east, full stop. Calculate the time spent by the aeroplane okay, to fly from X to Y to the nearest 1 hour, okay, to the nearest 1 hour. All right, and they say we should take our arrow to be 6,400 kilometer, and then we should take pi as 3.142. Okay, that's what they gave us. Right, solution. This is very simple. Solution. Now, first of all, let us draw it, because drawing to fetch you mark. So drawing it, you have this. So this is my north, south, east, and my west. All right, so we have that 15 south, 15 degrees south, 10 west, 10 west, 15 south again, I've drawn it, 45 east, 48 east, 48 degree east. All right, so this is their meeting point, these two places. So take them to the middle and call this one your X, call this one your Y. All right, and I told you that your alpha is gotten from the common one. These two are common, so my alpha is 15 degrees. Then my theta is gotten from the other one, and they are not on the same side, so I must add. So 48 plus 10, which is what? 58 degrees. All right, so now if we want to get the distance between them, you see that the distance between them is on the line of latitude. Why? Because they have common latitude. Yes, so therefore the distance between them, distance between X and Y is equal to theta over 360 times 2 pi big arrow cos what? Cos alpha, which is what? 58 over 360 times 2 times 3.142 times cos 15. So if you do everything, you're going to have 6258.55 kilometer. All right, so but they gave us speed. We know that speed is equal to what? Distance over what? Over time. And I'm looking for time, so time should be what? The distance divided by the speed. You know, anything in kilometer per hour is a speed. So I'm having the kilometer first, distance 6258.55 divided by 650. So what do you have? You have 9.629 hours. So if you approximate, you are going to have 10 hours, because they say we should approximate to what?